And welcome back to Backspace Academy. In this hands-on lesson on Virtual Private Cloud, I'm going to run through the default VPC, which has been created by AWS for us in all of the available regions in our account. And then I'll look at creating a custom VPC using the VPC wizard. And this will serve as an introduction to VPC and will set us up for the later lab that we will be having in highly available and fault-tolerant architecture towards the end of this course. In our account in all of our regions, AWS has created a default VPC, and that will consist of a VPC with the IP address space 172.31.00/16, and for each availability zone there will also be public subnets that have been created for us. So if you're in Mumbai and you have 2 availability zones, this is what it would look like for you. If you're in, for example, US East Ohio, you will have 3 availability zones. And so those IP address spaces for those subnets will be 172.31.00 and 172.31.16.0. And if there is another availability zone, it would be 172.31.32.0. Now they are public subnets. So what that means is that there is already an internet gateway that has been created for the default virtual private cloud. And there is also a route from the public subnets through to the internet gateway. So that means that we already have a route set up for connecting through to the wider internet. So if we launch instances within the public subnets, they will automatically have a route through to the internet. And they will have internet access provided they have a public IP address as well. So here I am now in the VPC dashboard. Again, you would go to Services and select VPC to get to the VPC console. So what we can see here now is that AWS has already created for us in each region a default VPC. So we can see here we have a VPC. We also have an internet gateway, a default internet gateway that is attached to our default VPC. We have 2 public subnets. I'm currently in the Mumbai region, and the Mumbai region has 2 availability zones, so because of that there are only 2 public subnets that have been created. If I was in US East Ohio, for example, there would be 3 subnets because there are 3 availability zones. There is also a route table that has been created, and that allows traffic between the public subnets and the internet gateway. And there is also a network access control list that has been created, and there's also a VPC default security group also. So I'll just click on this VPC now, and there we can see it has the CIDR block 172.31.00/16. Let me just click on that to have a look. So one thing there, we've got a tab here for flow logs. So what that means is that we can create a flow log, and that will record as logs traffic, information about traffic through our VPC, into and out of our VPC. And that will be stored as CloudWatch logs. And that provides us with a very good auditing tool and a security tool. And also if we have any problems with our VPC and we want to go back and have a look at the logs for our VPC, we can have a look at that and for troubleshooting purposes. So flow logs are a very good thing to create for your VPC. So let's go back to the summary, and we can see here there is a route table that has been created for this VPC, and that will be a main route table. And we also have a network access control list. So just clicking on the left hand side here, we have subnets, and we have 2 public subnets that have been created. And we can see there they're associated to that VPC, and we have a route table that has also been associated with this subnet and a network access control list. So having a look at the route table, we can see that this is a public subnet. It is a public subnet because it has a route between an internet gateway and the public subnet. So that is what we've got here. So we have a route for local traffic within the VPC, and we also have a route from the subnet through to an internet gateway, and that is what creates a public subnet. By having that route to an internet gateway, that creates a public subnet. So we have a look at our route tables here, and we can see that there are that route table that we have associated to our public subnet, it has not been explicitly associated. So what that means is that because it is associated as a main VPC route table, any subnets that are created will implicitly have that associated to it if there is not a route table that has been explicitly associated to it. So if you create a subnet and you don't explicitly associate a route table to that subnet, this is the route table that will be implicitly associated to that. So if we click on that, we can see then that we have our routes there and our subnet associations. And here it says again is that the following subnets have not been explicitly associated, but they have been implicitly associated through the main route table. And here we have our internet gateway, and again we have our route to this for our public subnets as well. In our security groups, we have a default security group that has also been created. And if we click on that, we can see that it allows traffic between inbound traffic from other EC2 instances that are in the same security group. So if we have a whole heap of EC2 instances, they're all in the same security group, they will be allowed to communicate, and we have outbound rules allowing all traffic out. So that is all I really need to discuss about the default VPC. We'll just get into creating our own custom VPC. So we'll leave it for now, and we'll talk about the custom VPC using the VPC wizard. Not only can we use the default VPC to launch our instances into, we can also create our own custom VPC, and we can do that manually from first principles. And in our lab later on wholly available and fault tolerant architecture, we'll be going into more advanced topics in VPC, and we'll be doing that manually from first principles. But in this hands-on lab, we're going to be using the VPC wizard just as an introduction to creating a VPC and seeing what is involved with that. So we're going to use the option with the VPC wizard to create a VPC with public and private subnets, and it will also create a NAT instance or a NAT gateway for us. So what that will do in our public subnet, it will already create a route from our instances that are launched in that public subnet, and that will create that through to our internet gateway and out through to the wider internet. Now, because our private subnet does not have access through to the internet gateway, because we don't want access to the wider internet through to our database, we want to keep that secure. So what we do is we create a NAT instance, or we can launch or create a NAT gateway, one of the two, in our public subnet, which will allow traffic to flow from our DB instance through the NAT instance or a NAT gateway, whichever we choose, and flow out through to the internet. So that will go through here into our NAT instance and out through to our internet gateway again. And that is what we're going to create now, and we're going to use the IP address space of 10.0.0/16, and we'll use /24 as the public subnets as well. Okay, so here I am back in the VPC dashboard. I've just zoomed the screen in so you can see a little bit better. Just click on Start VPC Wizard. Now you'll see that there are 4 options available there for creating a VPC. So we can create a single public subnet. So the same as we had with our default VPC. We had a public subnet and we didn't have private subnets. We can also look at creating public and private subnets, and that is the option that we'll use for this lab. And there are also two options there for hardware VPN access as well, which we won't be doing. So let's have a look at this public and private subnet. So what that will create for us will be a public subnet, which again will have a route through to an internet gateway out to the wider internet to allow access to the wider internet for any instances that are launched within that public subnet. It will also have a private subnet which will not have a route through to the wider internet through an internet gateway. So to allow any databases that are launched inside of that private subnet, to allow them to have access to download updates and the like, we will create a NAT gateway or a NAT instance. In this situation, in this example, we're creating a NAT instance, and that will allow traffic to flow from the database to the NAT and through out to the wider internet without compromising the security of our database by allowing public access to our database. So we'll just select that one, and there we can see that it's already populated that with 10.0.0.0/16 as a CIDR block for this VPC. We can use that one and we'll leave that as it is, but we can use any address space provided it is in the private address space and provided that it does not overlap with another VPC address space. And so we'll just give that a name. I'm just going to call it VPC Lab. And now we define our public and private subnets. So again, it's populated 10.0.0.0/24 for us. So we'll leave that as it is, but again, we can put in there, say, 10.0.5.0.24 if we wanted to. The availability zone, I'll just select the A availability zone. Now, if you're in Mumbai, for example, you'd only have two options there because there's only two availability zones in Mumbai. I'm in US East Ohio, so there's three. And I'll just select the A, and I'll leave the private subnet address space there as 10.0.10/24. That's fine, and I'll use the same availability zone that I used before as 2A. Now there's also an option there to specify a NAT gateway. Well, it's not really an option, it's compulsory. You need to actually either define a NAT gateway or use a NAT instance instead. So if we try and create the VPC now, it'll come up with an error. So we need to either put in a NAT gateway, and for this example we're going to use a NAT instance instead. In an enterprise application, you probably consider using a NAT gateway because it is a fully managed service that has some advantages because of that. But to save costs, and because we're using it for just specifically for a lab, I'll be using a teeny weeny little T2 micro, and all you need to do there is select your key pair name that you've used previously for launching EC2 instances, and that will create a NAT gateway inside our public subnet. There is also another option here for adding a service endpoint for VPC, in particular the S3 service. What that means is that normally we would launch an EC2 instance in a public or private subnet, and if it needed access to Amazon S3, we would need to associate a role to that EC2 instance, and that role would need to have permissions to access the Amazon S3 service. The reason we need that is because the Amazon S3 service is not located inside of our VPC, so we need permissions for that EC2 instance through a role to access the Amazon S3 service. So that is one way of doing it. We can associate a role with each individual instance, or we can create a VPC service endpoint for Amazon S3. And what that will do is that it will create an endpoint at our VPC, and when our EC2 instances need to communicate to Amazon S3, they can do it as though the S3 service is located within the VPC without using a role. So we can add an endpoint there, and we can see there's only the S3 services available for us to use. And we can have that available for our public and private subnets, or just our private or our public subnets. So I'm just going to select public subnets here. And we can define full access, or if we want more fine-grained control, we can define a custom policy if we like. For example, if we wanted to just restrict our EC2 instances to a specific bucket, we can create that there. Or if we only wanted to have access for read access, we could do that with a custom policy. But we'll just leave it as full access for now. And we'll leave the other two options as they are, and we'll create that VPC. So after a few seconds, you'll see that the VPC has been successfully created. If you find that you've gone through the form and you've filled out all the information's correct, and you still cannot create your VPC, you may need to actually go back and redo that. It seems to be a bit of a bug with the VPC wizard. Every now and again it doesn't want to create stuff, and then you go back and put this exact same details in again and it creates. So just go back and redo it, and it should launch for you okay. So we just click on OK now. Okay, so there you can see our VPC lab VPC has been created. So we'll just click on that to have a look. And we can see that there is a route table that has been defined, and that is our main route table for the VPC. So in a situation where a route table has not been explicitly defined for a subnet, it will be implicitly associated with this main route table. So with our private subnets, they will not have a route table explicitly associated to them, but because they don't have that, they will automatically be implicitly associated to this main route table of the VPC. So we can look at that route table now. And if we select it and have a look at the routes that have been defined. So we have a route for local traffic within the VPC, but we also have traffic that needs to go to the wider internet, has to pass through the elastic network interface for our NAT instance that has been launched. So if we go into our EC2 console and we have a look at that, we'll see that there will be a NAT instance that has been launched for us. So you can see there's one running instance, and there we can see is our T2 micro instance that has been created for us as a NAT instance. So if we select that, and if we go down to the network interface down here, and if we click on that network interface, we can see that the interface ID there will correspond to that in the route table. So we just go back to the management console, and if we can see there that will be the same network interface. So we have a route in our private subnet that goes from our private subnet to the NAT instance, which is located in a public subnet, which will then allow access through to the wider internet. And we can see that this will be associated, and again, it is not explicitly associated, but it is implicitly associated with the private subnet there. So I'll just get out of that now and go back to the VPC console. We can also see that there is a network access control list that has been defined as well. So we just click on that. And so we can see that it's been defined to both of the subnets, both the public and the private subnets that have been associated to this network access control list. And again, it's got allow and deny rules. If we want to make it more restrictive, we can edit that, and we can change that allow rule to whatever we want. We can just make it for just HTTP if we wanted. So I'm just going to maybe save that. And so we're only allowing port 80 traffic there, and we can do the same on our outbound rules. We can just do port 80 on that if we wanted to. And so that is how we would create a more restrictive network access control list. And we need to do that for both inbound and outbound rules because a network access control list is stateless as opposed to a security group which is stateful. And we can see that that is associated to our private and our public subnets. So I'm just going to edit that, and I'm just going to change that to all traffic and save. And the same for the outbound rule. I'll just change that back again. And save. So let's have a look at our subnets. So I just click on subnets now and have a look and see what's been created for those. Okay, so we have our default subnets there that have been created by AWS for our default VPC, but we also have, I'm just going to sort this by CIDR block. So we have our public and private subnets here that have been created in our new VPC lab VPC. So let's have a look at our public subnet. And so that has a route table associated to it. So we click on that route table and see what that looks like. And so here we have our route, and we can have a look at the routes that are our route table and have a look at the routes that are associated with that. And here we have a route for local traffic, but we also have traffic going to the wider internet, has to pass through the internet gateway. And that is what creates our public subnet. So we'll just go back to subnets and let's have a look at our, again I'll just sort that by CIDR block. Let's have a look at our private subnet. And here we can see that it has a different route table associated to it. And so our private subnet, that again has the main VPC route table associated to it, and all traffic in the private subnet needs to pass through the Elastic Network Interface for our NAT instance. So that's all we need to go through at this stage for VPC. What I'll do now is I'll just launch an instance into the VPC and we'll see what happens. So I'll just go into the EC2 management console and let's launch an instance. So I'm just going to go into the AWS marketplace and I'll see if I can find a WordPress AMI. That one will do. Okay, so we'll just use a T2 micro, we'll be fine. Now what we want to do is that we want to launch that into our, not our default VPC, but into our new VPC lab VPC. And we're going to launch it into our public subnet. And we need to make sure that we auto assign a public IP address, because for internet connectivity, we need an internet gateway. We need a route from the public subnet through to the internet gateway. And we also need for the instance to have a public IP address for that. We'll leave everything as it is, and I'll just go to add storage. I'll leave that as it is, leave add tags, and now we create a security group. And that looks fine. The security group that is been already set up for that allows port 80 access. That will be fine for us. So we just review and launch and launch. Okay, so after a certain amount of time, you'll get this screen that the instances are now launching. They aren't completely launched if they've started. So we can just go in there and view instances. So after about 5 or so minutes, your instance will be up and running and will have completed all its checks and all of that sort of thing. So now we can just click on that instance and then we can select the public IP address and just go to that. And it should show our blog. So there's our blog that has been created by WordPress. So how that has happened is that we have launched our instance in a public subnet, and because we have a route through to the wider internet through our internet gateway, that is allowed, and also because we have a public IP address as well. So if any of that is missing, we won't have the ability to connect to the internet. And I'll just prove that. So I'm just going to go back into our VPC, and I'm going to have a look at the route table for our public subnet. Okay, so I'm just going to edit this, and I'm going to remove the route to the internet gateway. So if I take that out and I save that. Now if I try and connect in again, so if I go back to the EC2 management console, go back to that public IP address space, it won't allow that to happen. So all of a sudden, our EC2 instance cannot connect to the internet. So we just stop that, and we'll go back to our VPC management console, and we're going to put that back in again. So we'll add another route, and that will be 0.0.0.0/0. And the target will be to our internet gateway, and we'll save that. So now again, if we go back into our EC2 management console, we'll pick up that public IP address and we go to it. We will now see that we can again connect to the internet. So one thing to remember is that you need to have an internet gateway. You need to have a route from the internet gateway through to your public subnet, and you need to have a public IP address for your EC2 instance. Without that, you will not have internet connectivity. So that's all I need to go through for now. And again, you'll be going into a lot more advanced stuff in the highly available and fault-tolerant architecture lab that will be coming later on in the course. I'll see you in the next lesson.